Not difficult. Complex is just a term that we use for all numbers that exist. So complex is just a term that we use for all numbers that exist. You guys have done this before. It's just a matter of, do you remember it? So let's kind of talk about it. I'm going to challenge you to see if you guys remember what these break down into. You've done it before. All we're talking about is the subsets of all numbers, just to have an idea of it. So again, I told you that complex numbers are all the way at the top. Every single number in the world is a complex number. And that's why we said it's labeled complex, but it's really not hard. It's just the label of all numbers that exist. It's complex. Does anyone remember what to come after complex? Let's get some candy going, because it is like really dead in here. I got suckers. I'm going to take a guess of what 2 would be next when you break it down. What'd you say? Rational numbers, good. And what's the other one?
Irrational.
Good. So we got rational, we got irrational. Okay. Now, irrational numbers. No, wait, pause. Everyone pause for a second. Is that right? Yeah, it's not real in whole, but it's real in something. What is real? Real? What other one do you think goes with real? Imaginary. Sorry, I was like having a brain fart. Real and imaginary. So you have all numbers in the world, but you have real and then you have imaginary. Okay, something exists and something doesn't. This is more of what we're talking about today is an imaginary number. That more pertains to a lot of advanced science. So if you were to go into an advanced science field, you're going to see imaginary numbers a lot. Okay, and that's why we learn about them, because we do use them in real life. Whether you go into that profession or not, it's okay. But they do use it to find out a lot of the technology that you've done. A lot of the technology that we have today is actually used and calculated with imaginary numbers. Okay, the microwave, that kind of thing, all that stuff. All right. Now we're breaking it down into our rational and irrational, so I apologize. Rational is next, and then we have our irrational. Now, the reason why we learn about this, if you were to go into a college or the SAT, or mostly for college, if you're planning on going to college or planning to go to JJC, you're going to have to know what these mean. If a professor says an irrational number, the goal is that you would at least know what he's talking about. Same thing with rational. Okay, so again, imaginary numbers don't exist to some extent on a two-dimensional plane. However, they exist on like a 3D plane. I had a video last year. Oh my God, I have to find it. Okay, again, imaginary numbers they don't exist like on a flat plane like this, but they exist on like a 3-dimensional or a 4-dimensional plane. So that's gonna help us out in a lot of the stuff that. Again, like waves. I'll show you the video. It'll totally blow your mind. Anyways, so real numbers, again, things that we can actually see. Irrational. Irrational would be something like pi. 3.1415926, blah, 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 blah. It doesn't stop. It keeps going. Okay, that's pi. That's a really bad pi symbol, but that is pi. You live?
No, it's all right.
I fixed it. It's a little bit better. Okay. So it's pi. It doesn't stop going. It just keeps going and going and going. But rational numbers, they can be any number. They can be negative. They can be positive, as long as it stops. Okay, so like 1.5, negative 1.5. Okay, the square root of 4, things like that. Okay, does anyone know what comes next by any chance? Integers is correct. Can you catch? You should. Oh, man, snapped. Okay, integers. They're all of your numbers that you can see on a number line. So think your number line. -1, -2. So I'm just going to kind of go off the side here. I got like -1, -2, 0, 1, 2. They're all the numbers on a number line. Think of integers are all the numbers on a number line. Integers is probably the most common that you hear. Integers. If you were to go on to college and you would hear a professor say integers a lot. What's next? We got whole left and we got natural. It's whole. And I'll explain why. Okay. Whole numbers, I want you to think like of a hole. Like literally a hole in the wall. Kind of looks like a 0. Because we start at 0. Okay, whole numbers, you start at 0. Natural numbers are things that start with 1. So 1, 2, 3, etc. Okay, here's what I like to think of it. Natural numbers, I'm a natural person, right? I mean, I would think I'm a natural. My fingers, I don't have 0 fingers. Okay, it doesn't exist. I don't have 0 fingers unless I like was in some kind of accident and didn't have fingers. It's fine. Yeah. Okay, let's say I was in some kind of accident, didn't have fingers, but I don't have 0 on my hands. I can't count them. I can count 1, 2, 3, 4, 5 though. I can't count 0 on my hand. I can count 1. Okay, that's how I kind of look at it. Natural are those, and the whole numbers think whole, the 0 is included. So let's kind of talk about each one. And they're all subsets of each other. So if you're natural, you're whole. And if you're whole, you're an integer. And if you're an integer, you're rational. And if you're rational, then you just keep going up. 6, you try to find the one that it goes with. Which one does it belong with the lowest here? Which one does it belong with? The lowest one that it belongs with on this diagram. 6, the number 6. It does belong in whole, you're correct, but does it belong in natural too? Yeah. It does. So you want to go the lowest one. If it belongs with natural, it belongs with everything. So I'm going to go ahead and put all. Because I don't want to, I mean, you could write them all out if you want. Feel free. But it's not going to be all. Or it's going to be all. The square root of 6, this was a little bit tough. You got to put this in your calculator to figure it out. It is going to be irrational. If it's irrational, what else is it when you go up? Real, and if it's real, it's complex. See how it kind of just connects together? I hate the screen. Okay, this imaginary number, I'm going to help you out because I don't know if you've really seen imaginary numbers yet. Have you seen imaginary numbers in math? A little bit? Okay, what is 6i? 6i. Sorry. I is for imaginary. And if it's an imaginary, it's also complex. Thank you. Again, I understand that this is just math terms. I understand that. Okay, stick with me here. What about 1/6? It's just a fraction. Just a number. It's a fraction. It exists. What would you say 1/6 is? Just a fraction.
Rational.
It is rational. If it's rational, it is also real. And if it's real, it is also? There you go. Again, everything is complex. Rational numbers, fractions that stop. 1/6 is a perfect example. You can write it as a fraction. That's another way to look at it too. If you can write it as a fraction, it's going to be rational. If you can't write it as a fraction, then it's irrational. It's a good way to look at it. 0. 0 is whole. Very good. So if it's whole, it's also? It's a long one. It's a what? Integer? And if it's an integer, it's a? Yep, rational, real, complex. Again, just being able to categorize numbers. It's more important, again, once you get to college, so all of you are going, and you do these big, awesome math classes, and you have to refer to them. When I was in college, I had to prove so many math theories based off of what I knew about each one of these. Okay, I knew the properties of an irrational number. I knew the properties of a whole number, and that helped me prove so many things. And then my computer crashed and I lost all of it. Okay. We are going to actually skip a lot of this stuff because as I said, I'm fixing chapter 4. Chapter 5 is fine. But I'm going to skip all of this, but I only want this part. This guy right here. Powers of I. Do you see that in your paper? There's this imaginary number I. If you were to take anything away from today, it's knowing what I is and what I squared is. Because that's what you're going to need to know if you were to take an exam like an SAT or on our final or in the future. Okay, I is an imaginary number. Usually that refers to imaginary. You're not really going to see the letter I really used for anything else. You're probably not going to see it as a variable. So I is actually the square root of -1. Can anyone for a sucker tell me why it's imaginary? Because there's a reason why that's imaginary. Yeah, both of you. Yeah. It's a negative sign. You can't have a negative number underneath the radical. It doesn't exist. There is no number you can square to get a negative number. I can't do -2 times -2. That's going to give me +4. I'm never going to be able to square something and get a negative number. And that's why it's imaginary. It does not exist in this dimension. Okay? Now, a question for you guys. If I were to take this and I would square it, what do I have left? Like if I were to take -1 and square it, what do I get? 1. Just 1? It is -1. Here's why. When you guys do, just again, you don't have to write this down. I'm just going to explain it to you. If I have like adding 3 and subtracting 3, what happened? They went away, right? I crossed them out. Because they're opposites of each other. Squaring and square rooting are opposites. They're inverse operations of each other. So they disappear and it becomes -1. That's what that is. Okay? So -1. So if you were to walk away with anything today, it's that I squared is -1, the number, a real number. And then I is our imaginary number, and that's the square root of -1. Okay, you won't have to memorize it. You will be given it. But again, on the SAT, you're not going to be given it. You're going to be expected to know that I squared is -1. So it's your imaginary. And it'll say, like, if I is your imaginary number, blah, 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 blah. Okay? Flip to the next following page here. We're going to do some practice. You guys are going to be so good at this because we spent a whole week on orders of operations and solving. But we're not going to be solving. We're just going to be doing orders of operations. That's it. Orders of operations. So let's look at the first one. Treat I like a variable. What's common? Bless you. Bless you. What are like terms here? Name one.
4i and I.
Thank you. 4i and I. Right here. If you don't have a highlighter, that's okay. Underline it maybe. Maybe that'll help you. What is 4i plus 1i? 4i plus 1i. I have 4 i's and I had another i. How many i's do I have left? 5i. Now look, these are all numbers. It's just orders of operations. You guys have done this so many times. I'm just going to go ahead and put that in my calculator in your head. 3 minus 6 plus 1. There's no equal sign. You're not solving. You're just putting it in your calculator. I know people are typing in their phones so they can see what the answer is. But make sure that you guys use a calculator if you need one because you won't be able to use your phone. 3 minus 6 plus 1. What? 4? Careful. Careful. -2. 3 minus 6 is -3. -3 plus 1 is a -2. Now I'm going to write, again, you've done this before. You've done orders of operations. This is something that we did like the first week when we were together, and you've done a lot in the past. But I'm going to tell you that if you were to see it on an SAT or any kind of standardized test or even in the future, they will write it as -2 plus 5i. Because that's just how we write numbers with imaginary numbers. That's just the standard form of it. Again, if you were to write the first one, I'd be okay with it. I would not mark you wrong. Just be aware that you can do that. You can just switch them. Why can I do that? Because 3 plus 5 is the same thing as 5 plus 3. That's our properties that we learned way back when. Okay, let's try another one. What do you think we're going to do here first for B? Yeah, parentheses, but what number is all the way out in front of this parenthesis? A negative 1 is what I was looking for. Because 3 plus 2, I can't really do anything with it. The reason why I have it set up this way is because of this dang negative all the way out in front. That's why I have to have them in parentheses. But let's go ahead and distribute. What's negative 1 times 1? Negative 1. What's negative 1 times a negative 6i? There we go. Bring everything else down. You can drop the parentheses now that we dealt with that. So we dealt with that negative, so we're good now. Do you have questions on that? That's just distributing. But guess what? We have like terms. What are they? 2i and 6i. Questions on that? Again, they're like terms. They're the same thing. Good. I get 8i. Then I have here 3 minus 1, which, yep, is 2. And I know that I like to put the number in front, so I'm just going to write it that way. If you would have put AI plus 2 on the test, I would have said yes. Good job. Way to go. Your imaginary numbers. I really have to get that video up because I know I had it last year and it was awesome. This one's really easy, but here's the cool thing, and this is why we use it in science and things like that, because we can actually pull out imaginary numbers. You might think they're imaginary at first, but they're really not, and we're going to see why. What is 12 times 7? Ooh, you were really close. 84. But don't forget about the i's. I times I is I to the second power. Thank you. I times I is I squared. I have 2 of them. Can anyone tell me what they remember I squared is? What is I squared? Yeah. So I'm just going to go ahead. I'm going to plug in negative 1. Look at that. There are no more variables. They're gone. They disappeared. What is my final answer? Negative 84. Good. Again, if you see I squared, the imaginary number I squared, it's no longer imaginary. That's negative 1. I know that. That's a fact. And that's across the board. Again, math is the universal language. You go anywhere, it's the same thing. Okay? D, here we go. 5i times 3, what we got? 15i. What's next? Just 10i squared? Good, negative 10i squared. I'll give it to you back there. But what is I squared? When you see I squared, the first thing you think of is I need to replace that with some number, and that number is negative 1. So, with that said, here we go. I have 15i minus 10. I'm replacing it with negative 1 because I know I squared, the imaginary number I squared, is actually indeed negative 1. So really that just changes my sign. What am I left with then? 15i minus 10 plus 10, because a negative times a negative is a positive. So that's why I got positive. Yes. You're right. So like, yes, if I were to write it formally, you are correct. It'd be 10 plus 15i. You're right. Did you get a sucker yet? You got one. Okay. Questions? I think we got one more left. And we're only going to do one more and call it a day. Pretty straightforward day. Ready? Here we go. Remember this one? It kind of looks like a claw. The first outer, inner, last foil. I don't really know what they call it for you guys. Distribute. But we're going to do first, outer, inner, last. So first terms. What is 6 times 4? What? You got it. Go for it. I'll wait. 24. There you go. Then what is 6 times negative 3i? You're close. What's 6 times 3 though? 18. So I have negative 18i. You're close though. What's negative 5i times a positive 4? Good, negative 20i. Last one here. What's negative 5i times a negative 3i? Careful with positive 15i squared. See the claw? It's like Mr. Krabs. First, outer, inner, last. The little claw. Okay, we're not done though. There's so many things that can be done. The first thing is if you can combine something, please do it. So I can combine my middle terms. What is negative 18i if I owe you $18? I took 20 more from you now. Now how much do I owe you? Negative 38i. Very good. Bring down the 24. What do I know I squared is again? Negative 1. Very good. So lots of things going on. Everything that we're doing right now is all the same as before. The only new step is introducing this I squared. It's the only new step. Okay, well, here we go. In your calculator, what's 24 plus 15 times negative 1? Or, you just know it changes the sign. What's 24 minus 15? 9. So I have 9 minus 38i. Again, everything's the same as before. You've done all this for a while. The only thing that's new is that you're replacing I squared.